Hi, Tony here. I'm about to record another lesson right now, and I want to let you know that I'm working from this textbook. Link in the description to buy that textbook if you don't already have it, and follow along number by number. Let's go. All right. This is the lesson 2.1 independent practice, page 41. And the first one, we have critical reasoning. Lisa used a number line to model negative 2 times 3. Does her number line make sense? Explain why or why not. So here, negative 2 times 3. I say no. The number line shows the correct answer, so she arrives at negative 6. But she modeled 2 times negative 3. See, this is negative 3 done 2 times. 1, 2. Instead of what she needed to do was negative 2 times 3, which means 3 of these. 1, 2, 3. And so there's that difference. Number 18, represent real-world problems. Mike got on an elevator and went down 3 floors. He meant to go down to a lower level, so he stayed on the elevator and went down 3 more floors. So how many floors down did he go? Well, he went down 3. So if that's 0, he went down 3. So went down 3. So that's negative 3, right? And then he goes in the negative direction again, another 3. So where did he arrive? Well, that's negative 3. That's negative 6. So he arrived negative 6 floors below. And so where did he went 6 floors down, and where did he go, how many floors did he go down altogether? 6 floors. All right. Number 19. When Brooke buys lunch at the cafeteria, money is withdrawn from her account. The table shows amounts withdrawn in 1 week. By how much did the amount in Brooke's lunch account change by the end of that week? Okay, so we have this here, and it's let's see. There's 1, 2, 3, 4, 5 of these 4s, and she's spending money, so that's negative $4 each time, and there's 5 of them. So 5 times negative 4 is negative 20. That's a 20, and that negative 20 represents a $20 decrease. Number 20. Adam is scuba diving. He descends 5 feet below sea level. He descends the same distance 4 more times. What is his final elevation? Well, he descends 5 feet, so that's descending. That means you go down. And so that means you're going in the negative direction. And he does it 4 more times. So he descends 5 feet below sea level, and then he descends the same distance 4 more times. So he went 1 time and then 4 more times for a total of 5 times he did that. And 5 times negative 25 is 5 times negative 5 is negative 25. So Adam is 25 feet below sea level. Number 21. The price of jeans was reduced, which means it goes in the negative direction. $6 per week for 7 weeks. By how much did that price change over the 7 weeks? Well, you multiply these two together, and it ends up being negative 42. So the cost decreased by $42 altogether. Number 22. Casey uses some of his savings on batting practice. The cost of renting a batting cage is 1 hour. For 1 hour is $6. He rents a cage for 9 hours in each of 2 months. What is the change in Casey's savings over 2 months? Well, let's go with the first month. It was a cost. So the cost is $6. So that's represented by the negative 6 here. And he did it for 9 hours. So you have to multiply that by 9. And 9 times negative 6 is negative 54. But he does it for 2 months. So for those 2 months, you have to multiply that negative 54 times 2. And that's negative 108. So Casey has $108 less in his account because he spent that much money. Number 23. Volunteers at Sam's school use some of the student council savings for a special project. They buy 7 backpacks for $8 each and fill each backpack with paper and pens that cost $5. By how much did the student council's savings change because of this project? Well, what they have is 7 backpacks for $8 each. So what was that total? It's 7 times -8, which is -56. So for the backpacks, we're talking about $56. For the paper and pens for each of those backpacks, that's $5 spent for each of the 7 backpacks. So that's $35 spent on paper and pens. So if we take the backpacks plus the paper and pens, that's a total of $91 for each for all 7 backpacks. So the savings account decreased by $91. All right, so the back side, we got number 24, describe a real world situation that can be represented by the product 8 times -20. Then find the product and explain what the product means in terms of the real world situation. So in mine, Hank plays a video game in which he loses 20 points. So when he loses 20 points, there's that -20 for every time he misses a goal. He missed 8 goals. So he did that 8 times. There's the 8. How many points did Hank lose? Well, let's figure that out. 8 times -20 is -160. So Hank lost. So what does the product mean in terms of the real world situation? It means that's the product, -160. That means Hank lost 160 points. Okay, so what if the rules for multiplying 2 integers can be extended to a product of 3 or more integers? Find the following products by using the associative property to multiply 2 numbers at a time. Let's zoom in close here. We have 3 times 3, which is 9, times -3, and 9 times -3 is -27. So that one's -27. Here, we have 3 times -3, which is -9. And then there's the -3 there. And negative times negative is positive, so that's positive 27. And then for this one, we have negative times negative is positive, so that's positive 9 times -3, and 9 times -3 is -27. And then we have this one. 3 times 3 is 9. 9 times 3 is 27, so there's the 27. And there's the -3 there. 27 times -3 is -81. I decided to go a little bit different direction here with this one. 3 times 3 is 9, and -3 times -3 is also 9, and 9 times 9 is 81. And then we have this one. 3 times -3 is -9. -3 times -3 is positive 9, and -9 times 9 is 81. Okay, so we have all that there, and we're asked to, based on your results, complete the following statements. When a product of integers has an odd number of negative factors, the sign of the product is negative. So when you have an odd amount of negatives, you get a negative. Let's take a look at this. Like here, we have 1 negative. That's an odd amount of negatives, and our answer was negative. We'll look at this one. We have 1 negative here. That's an odd amount of negatives. The answer is negative. Let's see. Here, we have 1, 2, 3 negatives. 3 is an odd amount of negatives, so our answer was negative. Then we have when a product of integers has an even number of negative factors, the sign of the product is positive. So we have this one. 2 is an even number. That's an even amount of negatives, so the answer is positive. Yeah, this one too. This is an even amount of positives, even amount of negatives, so the answer is positive. All right. Let's go back out and take a look at the product of 3 integers is -3. Determine all of the possible values for the 3 factors. Well, we could have, the only way you're going to get -3, or forget the negative. The only way you're going to get 3 is multiply 3 times 1 times 1. That's the only way you're going to multiply 3 numbers together and get 3. So where would that negative be? Well, we can put the negative in front. Remember, we want it to be negative, so we have to have an odd amount of negatives. So we can have 1 negative, or we can have 3 negatives right there, or I just put a negative out here. One of the ones would be negative. So you have 1 here, an odd amount, an odd amount, an odd amount. Okay, when the product of two integers is less than, when is the product of two integers less than or equal to both of the two factors? My response, and I'll explain it. Whenever the factors have opposite signs, the product will be less than or equal to both of the two factors. Okay, so what does this mean? So right here, the two numbers that you're multiplying by, those are called factors, and the answer is called a product. So when is the product less than or equal to either of these? Well, when one of these is negative. So 3 times negative 4 is negative 12, and the negative 12 is smaller than negative 4, and negative 12 is smaller than 3. So that product is smaller than either of the factors. And then number 28, our last one, the sign of the product of two integers with the same sign is positive. What is the sign of product of three integers with the same sign? So the sign of the product is equal to the sign of the integers. The sign of the product of the first two integers will always be positive, no matter what, if they're all the same sign. Multiplying that number by a positive will make a positive product, and multiplying by a negative will make a negative. So if they're all the same sign, basically, if they're all the same sign, like 444, it's going to be positive. If you have three of them, exactly three of them, and all of them are the negative, the answer is going to be negative. Because when you multiply the first two together, whether they're positive or they're negative, it's going to be positive. Positive times positive, that's 16, and that's positive 16. But what I'm saying here, the sign of the product of the first two will always be positive. So I just did that. Multiplying that number by a positive will make a positive product. So multiplying this by a positive will give a positive product. Multiplying it by a negative will make a negative product. So multiplying this by a negative will make a negative product. And that is what you need to know for multiplying integers. Thanks for watching.